Hello guys, my name is Gopesh Pandey and I welcome all of you to my YouTube channel, Grow by Growing Others. So guys, today we are going to understand what is bubble sort in data structures, how the algorithm works for bubble sort, and then finally after getting clarity on the algorithm about the bubble sort, we will get into the hands-on practice. We'll write the code, working code, where we'll see the how bubble sort basically sorts the elements in the list, right? Okay, so let's get into the problem first, understand the algorithm. So guys, if you can see my screen, here I have a list of elements where I have certain numbers given. And if you see like it is starting with 5, 9, 2, 1 and all of this. So finally what we are aiming is like we'll sort this list where in ascending order, where the most smallest number, it will start with the most smallest number and then it will keep on like it will go up to the largest. So what is the smallest here? 1 is the smallest, then 2, and then 5, then 9, then 34 is 2 times, so 34, 34, and then 67, and then 88. This is how your final output should look like. Now we'll talk about bubble sort. So what is bubble sort is all about. So guys, I mean to keep it simple, so bubble sort, as the name suggests, bubble. What does bubble mean? Like if you have observed in water, right? In water, when in or in water bottle, when the bubble forms, right? So if you, this is a prince, I mean, this is practically you can experience it like the bigger bubble. First, you will see the bigger bubble. If you see the bubbles, first you will see the bigger bubble, and then it's smaller than that, then it's smaller than that, then it's smaller than that. Meaning the most big bubble will be seen first. It will pop up first, and then likewise the sequence will go on. And how it is related with the data structure bubble sorting. I mean, the concept is same, but we'll understand how it will go on. So, guys, this is our list. Let's go one by one. So, first, what it will do, it will just start comparing these two numbers. These two numbers, 5 and 9. So, here 5 is already less than 9, so it won't do anything. It won't do swap here. Next, what it will do, it will check 9 and 2. So, it will check 9 and 2. So, what will happen this time? Since 2 is less than 9, so they will be swapped. So in the second iteration, basically second iteration, what will happen? 2 will go here and 9 will come here after swapping. Now it will compare 9 and 1. So again, in the third iteration, what will happen? Since 1 is less than 9, so 1 will come here, it will be swapped and 9 will come here. Again, what will happen? Very similar as what we discussed, 9 and 67, it will compare. So 9 and 67 is already good. So it won't do anything. It will skip, right? Now it will pick 64 and 67 and 34. Since 34 is what? Less. 34 is less. Then 34 will come here. 67 will come here, right? We will do a swapping of elements if they are like less, right? If the number is less, that should come before the other one. Now, if you see the next comparison, so I will copy it again, and now you'll see that you have 67 and 88, so there won't be any swapping because this is already in good place. And now in the last you'll see you have 34. So 88 and 34 will be compared. So this time 34 is less than what? 88. So 88 will come here and 34 will come here. I think hope this is clear. So I don't know if you have observed, but one thing is happening here. So in the first iteration of your all elements, when you iterate through all the elements in first attempt, you find that the most highest number in the element this list, the most highest element from this list is shifted to last. So do you see this? 88 is the highest, and now 88 is in the last. So like once you traverse through all the element in your list, the biggest element will be shifted to the last one. This is how bubble sort works. So you see what I was saying, like the big bubble will shown first. So this is a big bubble. is sorted already. Is shown first meaning it's sorted. Now it's placed in last. So when you do same thing again, like if you do same thing again, so this time it will compare 2 and 5. 2 will come here. Let me do it for your quick understanding. Then we'll go from there. So you see like 2 will be here, 5 will be here, 5 will be here. Now you can compare 5 and 1. So 1 will here, 5 will here. We'll swap. Now you will compare 5 and 9. There won't be anything happening because this is already sorted. Now we will check 9 and 34. There is also no room for swapping because it's already sorted. Again, it will check 34 and 67. There is no room for sorting because this is already sorted. Now again, it will check 67 and 34. So this time 34 will come before 67. So I hope you must have realized now the second largest number 67 has come just before 88 because this is the second highest number and all is coming before than this. Okay, you're clear with this, right? So this is how it works. Like in every set of iteration through all the elements, the biggest number will be placed in the last. So it will start with the most highest, then highest after then highest after that, then highest after that. So this is how it works. So I think you're clear with the algorithm. This is very simple algorithm of sorting, bubble sort. So yes, so you have to just like keep on going, and finally you will get this working. Now let's get into the code. We'll write code for it. Here in algorithm, lead code. Okay, okay. Here I can create one py file. I will call it bubble sort. Bubble sort. Okay, I will do py. So guys, as I was saying, um, we can get started here. So let me uh, get the examples here. Like this is our example. Okay. Now we can get into here. So first of all, I will do, we'll create just a here name, and then we'll say here, we'll basically create our main with entry point here, main, and then you will come here. I will create one function. We'll call it bubble sort, bubble sort, and here we'll pass the elements, elements, and yeah, I mean this should be fine. We'll create one function. Let's go like what we have understood. Like we'll try to solve that in a same manner. Okay, we'll write create function here. Will okay, elements we are fine here. Okay, elements. Elements. What is the problem here? I don't know. I don't know what is the problem. What? Indentation. Okay. 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 Sorry. I have to do like this. Okay. Let me reformat it. Reformat so that it looks nicer. Got the element. First thing that you have to get is size. Just say length of what? Length of elements. Okay. Now you got it. Now what we need to do is you have to just say for maybe I will call it in index, like element, uh, let's call it j. Okay, for j in range of what size. You got it. And now okay, so we have, and now let me print all of these elements. Let's first test it. You see, you got like you're getting the index. So if I say elements of j, elements of j, you will get the element, right? So you see, right, you're getting 5, 9, 2, 1. This is what like we got 67 and now what we need to do here is what we're saying, if element j is greater than element which is at j plus 1, right? So what we are saying, we are checking here if 5 is greater than 9. If 5 is greater than 9, then what we need to do, we have to do swapping. And for swapping, we have a very standard approach for swapping. So we introduce a third variable, temp. Here what I will do, I will simply let me put uh this one element j, which is in our case 5. Okay. And now what we'll do, like we will place element j plus 1 will replace with elements j. Okay. And now element j. Okay, element j. No, wait. We got, or let me do like this. I will store element j plus 1 here, and I will, okay, so here element j, you will say tmp. So this is, so let me run it. So let me run it. Okay. So what do you see? Okay, out of range. Because we are starting with 0, so here size minus 1 I have to say. Okay, this is fine. Now you see, let me print it. Sorted, bubble sorted, bubble sorted, and let me print it. And also what we need to do, we have to return, right? We have to return what? We have to return elements. So return elements, print, print, bubble sorted, bubble sorted. So what do you see? Okay, what's happening here is, okay, something is going wrong. Let's look into it. Ideally, what would have happened here, like after running it once, it should have placed 88 in the last. Okay, but that is not happening. We'll check why it's not happening. So what we're saying is, if element is j greater than, not less than. Okay, let me see. So now we see 88 has come to where? 88 has come to last. Now if I run it twice, so if you run it again, I think it's gonna start from fresh. So every time it's gonna give. So you are seeing one thing, like if you run this loop, basically the number of size, I mean with the same like you have to run the loop, and you have to run the loop how many times? It should be equal to the length of the this whole size of this list, right? Otherwise, like, so let me show you. So for example, I say for I in range of 2. So this time I'm going to run this loop two times. That is, I'm sure. 3 times basically. 0, 1, 2. Let me see what I get. Okay. Okay. So what's happening? I think I'm doing something wrong, maybe. Okay, I think I have to return here. Okay. So did you see one thing? So since you are passing 2, so 0, like it's running 3 times. So since you are passing 2 here, this inner loop is running 3 times. Since it is running 3 times, so it sorted basically, it placed last 3 bigger elements in the last, like 34, 67, 88. This is sorted. So as I was saying, like bubble is something like big bubble will be seen first, like 88 was seen first. Then second big bubble, which is 67, will be seen second. 34 is a third bubble, which will be seen at third iteration. So now since we have how many elements? We have elements 2, 1, 5, 9, this. So we have to ideally run from length of what? Length of elements. So if you run this many times, so what will happen? Your complete list is sorted. You see, your complete list is sorted. I think you are clear, right? Okay. So one thing that we have to still, we can improve. I mean, this is working. That is great. But one thing still we can improve here is, for example, so you see, right, like in first iteration, we got 88 placed in the last. Second iteration, we got 67 placed in the last. So, and every time, like in every iteration, like in first iteration, it check all the elements. Second iteration, it check all the element. So from the second iteration onwards, we do not need to check these elements. I mean, which is already sorted, like in the last, like for first iteration, it got first big element, big bubble placed at last. So every time when you do this inner loop, you don't need to, you don't need to compare the last one because those are already sorted. So just to avoid that, and this is just to make it more efficient, and this is nothing has to do with like wrong or right, but to make this code more efficient and more like optimized in a way like it should run in a less time. So one improvement that we can do is like every time when we run the inner loop, we do not need to go always like check and everything up until the last. So here you can just if add minus I, like basically for example if you're running first time, right, like for example 0 and first, so here size -1 -1. Let me see run it. So you are getting, so here you will get the good improvement. You will get the good improvement. So this is what one thing that you can note down. So this is about the bubble sort. This is the working solution. I hope you understand the algorithm. And just to try out, I can run it for another example. So like this is another example, guys, and let me run it. So it should work for this scenario as well. So let me comment it out here and uncomment this one. So you will see this is also working. But guys, one thing is something that you can note down here is like, for example, if your list is already sorted, for example, let me do like this. This is already sorted, right? So if something is already sorted, you won't run that every time, right? I mean, if it is sorted, so somehow if you can check in inner loop, if it is sorted already, then there is no point doing and running the whole sequence again and again, right? If this is sorted. So again, just another improvement that we can do here is we can make it more efficient by doing one thing here. Here I will say in a slide one variable, I will say swap false. Okay. And if it is going here, I will do true, swap true, swap true. Okay. And after this, right, if I say swap not, if not swap, if not swap, if not swap, then break. So basically you're saying if it is not swapped, meaning it's already sorted, you don't need to do anything, right? Maybe I can call this variable as a swapped, and here let me call swapped, here let me call swapped. So this one, this thing you can remember, and this is very simple. So this is sorted, and if you have seen like it's not going inside and it just like checked in first iteration, it went inside and it since didn't do anything, this part did not run, meaning like it does not require any kind of shifting because it does not do any swap. And one thing to note down, it will do one swap. I mean, it will do many swaps, but one swap will happen to basically place the bigger bubble at the last. Since it didn't do anything, so it just terminated the iteration and it came out. So this is running as it is. Another example that we can test out, like it works for like numeric elements, but also we can sort. Okay, I mean words or not alphanumeric, but alpha. Like for example, let me run this also. So here, if I say bubble sort like this, let me call it again and elements, and I will say here bubble sort here. So how it will sort? It will sort with the starting character. Like A is a which is a like I mean less than another like B, D or something. So it will basically sorted by character. Let me run it. So you see, Amir has come first, Chang, Dawal, Mona, Tina. So first corrective C, Amir, C, D, A, C, D, M, T. So this is working great. I hope you are clear with the algorithm explanation. You are clear with the logic, the way we wrote the code, and it's clear, it's a simple, and you can try this out by yourself. I hope you will be able to write. If you are facing any challenges, queries, please write me down in the comment box. I will try to address your question query in a prioritized way. Thank you so much watching my video. If you like the video, hit the like, share with your friends, and circulate with your friends. Okay, then let's meet in the next video. Bye. Take care.